today for my presentation. If you don't know what Canva is, please go check it out because it's amazing. It has lots of things that kids can do, mostly for middle school, high school kids, though. I don't know if we have middle school, high school on here, but Canva kind of caters to middle school, high school. You can create advertisements, you can create infographics, you can create presentations, you can create, Facebook posts, Twitter posts, anything like that. So it's pretty cool. But I used Canva today, so I'm going to go ahead and start sharing my screen. Give me a second. And while I am sharing my screen, I won't be able to see your chat. So if you have a question, please feel free to just turn on your mic. There's not very many of us in here right now. So just turn on your mic and ask that question or type it into the chat, and I will get back to you after we get done presenting today. Would help probably if I didn't start at the end of the presentation, huh? So just a little bit about me. My name is Heather Korrell. I work at GC Burkhead Elementary School. I am the STEM lab teacher. I've been teaching STEM for the last 4 years. And my vision for STEM lab when I got the position was that I wanted to teach kids about engineering and focus on those engineering science standards from the next generation science standards. But I also wanted to teach computer science. And so I began to seek out programs and curriculum that would work with that. And I found Scratch and Scratch Junior, and it really was a way to integrate coding across curriculum. It's not something that has to be standalone, only coding, only about coding. It very easily marries with math and reading, and we're going to look at that a little bit today. So when I actually say teach coding, along with your other content and everything else that you have to do and possible NTI that's coming up this year, which one is your response? You're either probably not, or you might be really excited thinking, yes, let's do this. Either way, I'm hoping that after today, you have some tools that you can take with you and use in your classroom. First of all, did you know that Kentucky has computer science standards? I actually had the privilege of working on the computer science team. This was back in 2018. Yeah, October 2018. So the year 2017 through 2018, we worked on these, and they are computer science standards for kindergarten through 12th grade. Some of you might have people in your building who are responsible for teaching this. You might not. I know that a lot of our elementary schools do not have STEM labs. You might have your librarian teach some of these computer science standards. Middle school, I know you guys have technology class. They're probably the ones focused on teaching computer science in high school level as well. But if you get a chance today, maybe take a look at these materials. I'm going to scroll down to where you can actually see it. They're actually broken down into 4 areas, and that is networks and the internet, data and analysis, algorithms and programming, and then, impacts of computing and how it impacts our daily life. For this portion, or what I'm presenting today, it mostly focuses on this 3rd standard of algorithms and programming. And basically, when I say programming, you are teaching the kids how to make the computer do what you want the computer to do. You're giving it step-by-step instructions. You're using things like sequencing. And most of this coding that you're going to see is done through visual programming blocks, not necessarily a coding language such as Python or JavaScript. We're talking about little blocks that kind of help the students learn the basics of coding. However, Scratch does offer a lot of areas for growth for high school, so it doesn't just reach the elementary kiddos. All right, back to this. So why Scratch? I love Scratch, one, because it promotes creativity. Literally, students are starting from Scratch. And I think that's one of the reasons that they named it that, because when they get on there, it's a blank screen, it's a blank canvas for them to work towards. Now, as beginners, in Scratch, but not Scratch Junior, Scratch, you can actually pull up other people's projects and work from their projects to create your own, which is pretty cool. But then once kids get comfortable with it, they're able to create anything that they want. It also promotes engagement. Kids actually love to code. Even the ones who might be a little shy about it at first, or they think they can't think of any ideas, once they see what you can do with it, they see what their peers are creating in it, they get really excited about it. And I always teach them that there's nothing you can do in coding and programming that really screws it up. I mean, I know sometimes, like my mom, she gets really nervous about doing something on the computer because she's afraid she's going to mess it up. But kids aren't like that. Like, kids like to try things out. And I always tell them, if it doesn't work out, it's okay. We're going to fix it. We're going to make it better. And that's how we learn. So it really promotes that engagement piece. Using Scratch and Scratch Junior can also marry your math and reading content with computer science content. They actually work really, really well together, as you're going to see here in just a few minutes. And lastly, it's easy and fun. Like, I enjoy creating alongside the students. When I give an assignment, not only am I kind of facilitating their learning as they're creating, but I'm also creating alongside them and showing them some neat tricks of things that maybe they hadn't figured out yet or hadn't learned about the program yet. So let's talk about what is Scratch. It is a programming platform. It is designed for grades 3rd through 12th, and it is completely free, like free forever. It was actually started by MIT, the Technology Institute, and they have continued to get grants and donations in order to keep it going. I think right now there's over, I want to say 4 million users is what I remember looking up. We talked about it when the kids were trying to make their own accounts because they were trying to do usernames and, they would come up with like their first name and a number. And it's like, oh, that one's taken. Well, you have to remember there's like 4 million users. Scratch is web-based. It is free student accounts. And like I mentioned earlier, students can start from templates. They can edit existing projects or start from scratch. Scratch Junior, however, which is really geared for our K through 2 students, is also a programming platform. It's completely free as well. You can find it in the Google app it's a Google app from the Google Store. You do not have to have an account to save things. It actually saves automatically in the app while they're logged in as that user. That's a really great thing because in my experience, when you're trying to get kindergartner or first graders to log on to things, sometimes even second graders, we have a hard time typing in our usernames and our passwords. And sometimes, especially at the beginning of the year, that takes us like the whole class period to get on and log off. You guys know what that's like. So when they log onto the Chromebook, it is literally just, I don't know if you can see this down here. This right here, we're going to be using that in a minute. It's a picture of a cat head. A cat, by the way, is the Scratch logo. So you'll see that as we go through. But Scratch Junior, they just have to click on that and it takes them right to the app. Super easy. However, in Scratch Junior, the students do always start from scratch. They cannot pull from another project and make it their own. They do have to start from scratch. But you're going to see in a moment when we start walking through that it's a little bit easier. It is kid-friendly. So there's no reading required. And that's one of the great things about Scratch Junior to use at the kindergarten level, the first grade level, even some of the second grade levels. The kids do not have to read what the blocks do. They are literally looking at pictures of what the blocks do. And I think that's great for our younger learners. So I'm going to show you real quick a couple of examples that I created. These are things that I used in my classroom, and then I'm going to walk you through how to actually make one. And then at the end, we'll give you some time to go back and actually try to make one yourself. So I used Scratch this past year. It was actually the first year that I incorporated Scratch as a whole class lesson, which was a big step for me. Before, we had just used the Scratch lessons that were in code.org, and all of those were step-by-step telling the kids how to build something. So I use Scratch to incorporate math for my fourth graders. So a big thing in our fourth grade classes is that the kids are learning they're learning to memorize their math facts, their multiplication facts, and the functions. So this particular activity, I think, helped them understand deeper how the function worked, understand the relationship between multiplication and division. And then it also helped incorporate their deeper understanding of computer programming. So I'm going to take you to this link. So at the beginning of the lesson, I actually created this Scratch project. We played through this, basically a function game where we were guessing what was happening inside the function bus. And you'll see there, if I have any Harry Potter fans on here, I named my bus the Night Bus. And I was in the process of trying to get the little like monkey head at the top, but I didn't get that far. Anyway, in Scratch, when you want to start the code that's already been made, you're going to hit the green flag. And so you'll see that I have a number 11 going into the bus, a number 55 coming out of the bus, and I wanted them to figure out what was the other number and what function was being used. Was it addition? Was it subtraction? Was it multiplication? Was it division? And so we talked through how, well, if an 11 is going in and a 55 is coming out, we know the number is getting bigger. We know there are two operations, two functions that make a number bigger, right? Addition, multiplication. So we talked through that a little bit. The kids figured out that, well, it was multiplication. And so down here, we would type in the answer, 5, and it would play a sound and tell me that they got it correct. If I hit the green button again, I'm going to get another number. Now, let's say that they thought it was addition, because frankly, that was a possibility. We knew that the number was getting larger. We didn't know how it was getting larger. So let's say in went a 10, out came a 9. Maybe it was plus 90. When we put in 90, played the stop sign, sound, said not quite right, and then asked again what the other fact was. So we were learning about math facts in this way. Once we talked about the math facts and we figured out that it was in fact multiplication and that was consistent through each of the numbers that we used, we started talking about the codes that would be needed to make this happen. And I'm going to go ahead and show you inside. When you go to a Scratch project, there's this little blue button that says See Inside. That's where you're going to be able to look at the codes that were written for that particular project. So when I click on See Inside, here's my code. So what the students had to do was they had to first create variables. We had to create a variable number 1 and a variable number 2. We set the number 2 or number 1 to be a random number between 1 through 12. And we wanted number 2 to be number 1 multiplied by random number 1 through 10. And then I wanted it to ask, what's the other fact? Now, the if else is called a loop block. Loop means it's going to continue repeating until something else happens. So if the answer was equal to 2 divided by number 1. So if the answer they put in was 2 divided by 1, then it would play the honk sound and tell them, correct, nice job. Else, meaning if it was not, it was going to play the skid sound, tell them to try again, and then ask again, what's the other fact? And you'll notice that there is this block around all of the if else that is a forever block. Forever means it's going to continue forever, meaning if they continue to get that number wrong, it's going to continue to ask them to try again until they get it correct. Once they get it correct, then they have to just hit the green button to give them a new set of numbers. And so it's kind of self-explanatory, I think. When green button is clicked, we want the function or the program to do this. So it picks a number 1 that's 1 through 12. It picks a number 2 that's number 1 multiplied by another number. And so we can see this again. 4, 4. The answer is 1. My answer was correct. So if answer equals 2 divided by number 1, then play the horn, and say nice job. So you can really see that math is being incorporated all through this. And it's more than just memorizing a fact. It is truly that students understand the relationship between multiplication and division. And they also understand how to determine if a number is being multiplied or added. All right. So now I'm going to show you Scratch Junior. I cannot show you an example that I made in Scratch Junior. I actually just put a screenshot. I am going to walk you through Scratch Junior here in just a second. Because that file is within the app, I can't actually share that file with you. But here's a picture of what Scratch Junior looks like. So you'll notice that we still have this picture of the background. We have the characters. In this case, I have a cat, I have a bunny, I have a tree. And down here are my code blocks. You'll notice the difference between these code blocks and these code blocks are the words. So when I want him to move 10 steps here, all I have to do is use the move forward button. You drag down. We're still using that green flag that tells it to start the program or the code. So that's important to know. But I think the Scratch Junior will make a little more sense. When I think about Scratch Junior, I really think about literacy connections, students creating scenes, students creating sequences of events. Because you'll notice over here, here's the scene that I'm working on. I can add another scene by clicking this plus sign button. And each time the scene can change. They could retell a story this way. They could tell their story this way. So that's something that I see for that. So, who's ready? It's time to explore. So I'm going to show you all the good stuff. So we're going to exit out of this. I'm going to go back to Scratch. We're going to start at Scratch. Again, Scratch is recommended for grades 3 through 12, third and up. And then I'll get to Scratch Junior in just a second. So if you visit Scratch, again, it's scratch.mit.edu. It is free to create an account. You'll see here, I've already created my account. Anything that I make is located here in my stuff. But if I want to create a new project, I just click on create. When you do sign up for Scratch, it just asks you a couple questions. It asks for your email address, your age, gender, and the country in which you live. This is what a Scratch blank program looks like. It always brings up a cat. Some kids like to use the cat. Some kids don't. Anything that you put on your screen is called a sprite. All of your codes are located over here on the left-hand side. Your blue codes are your motion codes, which means movement codes. Your looks are things that you want to show up on the screen. You want backgrounds, you want costumes. Sounds are sounds. Event blocks are when you want something to happen. So typically we always start with a when you click the green flag. You could also start when the space bar is pressed, when the sprite is clicked, when the backdrop switches, any of those. Your controls are where you're going to get the waits, your repeats, your forevers, your if-else blocks. And then we have your sensing, meaning if you're touching something, if the distance to the mouse pointer is such and such, asking questions, when the mouse is at a certain X spot, when it's at a certain Y spot. We also have your operators, which are your math. You can create your own variables, change those variables, show the variables, set the variables, and then students can actually create their own blocks too. That would probably be for our more advanced coders. I would think middle school, high school, level depending on their background with coding. Anyway, when you want him to do something, you just scroll through. Let's say I want him to move 10 steps. And then when I hit the green, he moved a little bit. Now let's say I wanted him to move a lot. I could make him repeat moving 10 steps 10 times. Makes them move a little bit further. And so kids can play around with the numbers. I try not to tell them exactly what the answer is. I ask them to play around with it to test it out. Let me show you another project that I did. So this was the one that we were actually working on before COVID, and we were supposed to finish it up, and then we didn't get to finish it up, which I was pretty sad about. But this is a game called the Capture Game. And so you will notice here that I have lots of events. You can actually have several events happening at the same time. So for example, when I click the flag, this tells it to set the score to 0. If it's touching the bowl, then it's going to give me a point and play a sound and go back to a random position. And it's going to forever do that. It also tells it to start at a random position and set the Y to 180, which is the top. And then forever, when it's falling down, change the Y position by -5. And then it asks it to go to a random position. So what was actually happening here? Oh, sorry. This has 2 sprites. I have the ball and I have the bowl. When I click on the bowl over here, I actually have a code that basically tells it to move when I press a right arrow key, change the X axis by 10, left arrow key, change it by -10, up arrow, change by 10, down arrow, -10. So that means when I move right, left, and you'll notice as I'm playing, I'm keeping score. So, sprites down here, you have different codes for different sprites. You have backgrounds here. You have tons and tons of sprites that you can choose from as well. All right. I'm running a little short on time, so I'm going to go ahead and skip over to Scratch Junior. Oh, fun fact. I think I might have already said this, but MIT founded and funds Scratch to help teach coding for all ages, and it's always completely free. Scratch Junior, you do have to visit the Google Play Store on your Chrome device, search for the Scratch Junior in apps, and install it on the device. Once open, students can click on the app, and they'll automatically be logged in. There's no additional account needed. So I'm going to show you the Scratch Junior account. Again, Scratch Junior is recommended for K through 2. You'll notice when I get on the screen, literally there's no words except Scratch Junior. They click on Home to get to their items. I'm sorry, this seems to be running kind of slow. It was not running slow when I tested it earlier. And when they log on, there's no other logon needed. It brings them right to this screen. If they have previously been working on something, it's going to show up here. We're going to start a new project so that you can kind of see what that looks like from the beginning. Again, Scratch Junior always starts with cat. If you wanted to delete the cat, you just have to click and hold, delete him. Let's add something a little bit cooler. Oh, this guy's cute. They click check mark if that's the one they want. And let's pick a background. Backgrounds are located up at the top. And she looks kind of like an outer spacey kind of person to me. Click. Check mark. And there's that. Now, once you start building the code, it's the same with the green flag. You have to start with the yellow buttons first. So this is when you click the green, when you click the person, when the person touches another person, if that makes sense to you guys. I'm going to choose this, and they just have to drag it and drop it. And then I tell them maybe to come to movements. Let's say I want her to spin around or turn left. Come on. Well, guys, I'm so sorry. I don't know why this is kind of glitching out on me. There we go. And let's say I don't want her just to turn left once. I want her to do it multiple times. So the orange are your controls. This is our repeat block. Come on. They can change the numbers here. If they would like to change the number, it's going to pop up over here for them to just touch the number that they want. This would be to wait. This would be to stop. This would be to move until something happens. Once you have a code written, you come up and touch the green. And so she moves that many times. Let's make that a little bit bigger. Let's make her go 12 times. I think 12 is the magic number for circling around. There we go. They can add scenes here. They can make these people say something. So let's say we want it to say hi. We want it to say really anything that you're wanting it to do. She spins around and says hi. They can also add their own recording, which I thought was pretty cool. They just click on this. Click record. Welcome to the moon. Stop. Check mark. And then there's my recording. So you can see there's a lot of sequencing that goes into this. It goes lots of critical thinking, I think, when you're thinking about the step-by-step process of what you want the sprites on your screen to do. I really see Scratch being great for math and reading as far as creating the scenes. They do talk about the X and Y axis. Scratch gives you a little more to play with as far as math functions and operations. For this one, let me make a new scene. You can choose to use a graph, which is kind of cool. Like if you're teaching coordinate planes or you're teaching shapes and you want them to draw specific shapes, if you want them to move specific places, that kind of thing. So I added some resources for you guys. And I'm going to give you guys about 20 minutes here to play around with either Scratch or Scratch Junior, whichever one happens to be a little more geared towards you. But what I did was I went through and I added some links to some resources that are already have lesson plans, that already have instructions on how to use Scratch in the classroom. So I have interactivity guides from Scratch, basically teaching your kids the basics of Scratch. Brennall Math. This was a guy that Brandy actually introduced to me through Scratch. He has tons and tons of math project ideas. That's actually where I got the idea for the function bus. He actually did a fact triangle. I just basically took his idea and kind of made it my own. And then this is Boot Up Curriculum, Scratch Ideas, tons and tons of good resources. And then the last link on there is scratch cards. Scratch cards are ideal for maybe center activities or students who are working independently. It basically tells them on the card step by step how to create something. I did one activity as a whole class where the students animated their name. So they had to insert all the letters into the screen. Then they had to animate each of those letters so they would spin around each time. And then if you are more of a Scratch Junior person, I added some math and literacy that's actually from Scratch Junior, some genres curriculum from Scratch Junior, Coder Kids projects, and then they also have Scratch Junior cards. Now, the link to the Scratch Junior cards and the Scratch cards link you to Amazon, which is where you can purchase those. But I promise, even if you have just one set, they're like $20 a piece. They're really, really good for introducing your kids to Scratch. So now that I've talked for like half an hour, I'm sorry. A lot of that took a little bit longer than what I wanted it to. It is now your turn. So I'm going to give you guys about 20 minutes to go through and try out either Scratch or Scratch Junior. I am going to put in the chat the link to, I'm going to put the link to my presentation. So if you want to check out some of those links that I put on the slide for Scratch or Scratch Junior, then you can. And Brandy has put in the chat also, don't forget to sign in so that you get credit for this time frame. I will be hanging out until 1:30. So if you're on here and you have a question about anything that you're going to use Scratch-wise, I'd be happy to help you. If you have a great idea for how you could use, sorry, I was reading the chat. If you have an idea of how you could use Scratch in your classroom, if you could use it for math, if you could use it for reading, science, social studies, if you have a great idea, please share that out. I would love to be able to share with anybody who would like to share so that we can all learn a little bit more about how to use some coding in our curriculum, because I think as we move forward in this world, a lot of the jobs are going to require kids to know at least some of the basics of coding, and a lot of jobs are going to come from computer programming. So thank you guys for hanging with me and listening. Like I said, I will hang out here for a little bit longer. I am going to turn my video off so that you don't have to stare at me the whole time. But if you have a question, either turn your mic on, ask the question, or pop that in the chat, and I'd be happy to help you out.